Welcome everybody to the afternoon sessions at AltConf. Our first speaker today is Kristaps Grinbergs. Please welcome.
Hello. Do you hear me? Okay. All right, let's start then. So, hi everyone, my name is Kristaps, and I would like to talk today about core animation and how to tame this brilliant and sometimes overlooked framework. But firstly, why there is Tame in my talk's title, and what does it mean? I got inspired about this word from book Little Prince. It's a great book for grown-ups, explaining what children feel. And it's really good exercise for our imagination. And in this book, Little Prince wanted to tame a fox, but Fox explained that if you tame me, then we will need one another. So during this talk, we'll try to tame core animation, because it's very wild animal, but really powerful and beautiful, and very hard to tame. But once you do it, you kind of live without it. So here's a little bit about me. So I have more than 15 years in experience in IT field, in various roles like starting from building Oracle databases, building web apps, web systems, and desktop applications for Mac and Windows. But I started to work with iOS ever since it came out, so since early beginning. My daily tasks are all about Swift developments, which involves iOS, tvOS, macOS, watchOS, and even server-side Swift. And I love open source, and I help to maintain multiple libraries and frameworks like RX Animated, WebSockets library Starscream, which is one of the most popular out there, and GraphQL for iOS called Apollo. And I'm also involved in Swift Weekly Brief, which is actually a bi-weekly newsletter about Swift, what's happening in open source Swift and in community at all. And we deliver these news right to your inbox. So later you can catch me. I have stickers as well from this Swift Weekly Brief. And if you haven't subscribed after this talk, go and check it out. By day, I run my company called QMinder, where I'm one of the founders and a Swift developer there. It's a smart queue management system that helps transform waiting lines into opportunities to provide great customer experiences. So we give our clients means to engage with their customers using Apple devices like iPads, Apple TVs, iPhones, in combination with personal touch. So how does it work? Is that instead of number ticket or these stupid ropes where they want us to stand, you just type in your name in iPad, and it's all about the name. So the TV, which is Apple TV application, shows who is waiting, when someone is being called, and so on. And our clients are serving millions of people every month. And QMinder is used in many well-known companies like Lyft Client Centers, where they onboard new drivers, Verizon, Apple, AT&T, resellers, Comcast, and more. It's always hard to start presentations, so I would like to start with a small story. This is my cat. His name is Mr. Byte. We can call him Kilobyte now because actually he's much bigger. And I really like to play with my cat and tame him, but training Mr. Byte is a very difficult task, and he doesn't want to do what I want, so it takes quite an effort to do it, to train him how I wish to do it. So it's similar with core animation. Sometimes it takes quite many iterations to do and when you get the outcome that you really wanted. One day, my designer came to me and presented this brilliant idea to create background animation for our Apple TV application. When she showed her idea, in the beginning I thought, yeah, it should be easy, right? At that point, I had some experience of UI view animations, and I thought, yeah, it's like piece of cake, just a couple of hours work, and that's it. But later in this presentation, I will share my journey, how I actually did it. And this is Mr. Byte enjoying CA basic animation. And here is great quote by Suroosh, who is in the area as well. So if you have a chance to meet him, say hi and talk to him. He's a really great guy. Once he said that animations in iOS are easy, except when they are not. And this is how I honestly felt when my designer showed me this idea, what I needed to build. Like simple things moving here and there, it's relatively easy, but when you want more, when you want something more sophisticated, then it gets really tricky. So today, my goal is to talk about core animation, give a small introduction about it. I will focus only on path property animation for shape layers. And then I will show real-life example of what my designer wanted to do it. Animation has been important part of macOS and iOS user interface since early beginning. And probably we all have seen this genie effect when it slides down to the dock so many times that we hardly notice it anymore. Actually, Apple integrates animation in their operating systems apps overall, and the thing is that users are expecting it. Like, we want these nice animations. But what is animation? It's a change in value or state over time. So if you look closely at this cat animation, then we can see that firstly, cat slides from left to right. So that is a value change on x-axis. And when cat nicely disappears in the end, that is a state change. But what is core animation? Core animation is a framework which helps us to build powerful animated user interfaces. Inside Apple, code name for this framework was LayerKit, because it heavily relates on layer concept. And it was presented in WWDC 2006 within macOS Leopard, so quite a while ago. And the creator of this framework was John Harper, who later joined Facebook. And I would like to point out that core animation was presented in Macworld 2007. So that was the conference where the first iPhone was presented. And when Steve Jobs unveiled the first iPhone, he said that iPhone runs stripped-down version of macOS 10. So that means core animation. So we had core animation since early beginning. But what is core animation definition? I was trying to Google here and there and went to various sources like Wikipedia and such, but most of them were quite complex and I couldn't grasp it. But then I went to Apple official documentation, and I think for core animation, it's pretty decent. They have clear explanation and also some other parts like examples. But let's break it down. That core animation gives us high frame rates to make really nice animations without burdening the CPU. So that means we are not slowing down our applications. But let's start with some clarifications. Is core animation same as UI view animations? And the answer is no. Yeah, and we nailed it. But how do I know that? Once I wrote this code, I wanted to animate corner radius over time, but the result was that nothing happened. It just jumped to the new value. And why it's that? Because I'm trying to animate here layer property, not UI view property. So these UI view animations are, let's say, lightweight, more like stock animations available for us. But actually, it's using core animation under the hood. Another technology we need to discuss today is core graphics. Core graphics is CPU power operation. So with this technology, we can draw stuff on the screen, more pixel-wise actually than core animation. But it's, yeah, and the thing is that we can use core graphics to draw stuff, and then later with core animation capabilities to animate everything what we have drawn. As core animation is CPU-bound operation on the main thread, it can be slower on older devices. So keep in account that. And sorry. Core animation is deeply integrated into iOS stack. So since we are using UIKit or AppKit, I know about this new Swift UI yet. I haven't dig deeper into that. So we're using core animation under the hood. And core animation is using metal, graphics hardware, core graphics, and then graphics hardware, like the lower level to the actual metal. But in the end, what is core animation? It's a Cocoa framework, which is responsible for most of the iOS, macOS, and tvOS animations. So it's generally a good way how we can write cross-platform code for our animations. And I would like to point out that it's not supported in watchOS, at least not officially. But tomorrow there is a great speaker here, Guy Rambo, and he knows more about this topic, how we can Spelunk watchOS and actually get these animations. So I have agreed with him that he's willing to share more if you ask him. And he's in WWDC area whole week. And core animation is accelerated by GPU. So it means it runs on the separate thread. So we're not burdening the CPU and the main thread with the animation stack. And it runs really close to the actual metal, the hardware. But when building animations with core animation, we need to think about two things. First one is time of completion, and the frames we need to get nicely to the end of the animation. Because actually core animation will drop all the intermediate frames to complete the animation on time, what you have specified, rather than show all the frames what you wanted to show. Because there are several factors which are coming together. Like what's the system load, what's the hardware capability, how old is actually the device. Like all these things are happening together. So you need to test the core animation on the actual device to see this animation, how it looks like, how it looks. To figure out animation behavior, core animation is using interpolation method to plot out these data points, how to increase animation value over time, from start to the end. So the default is basic animation, which is like linear one. So the value is increased over time, like for each frame. And we can make our own kind of these interpolation methods, but the math is quite tricky and tedious. So thankfully, core animation gives us possibilities to use built-in ones, so we don't need to mess with this so much. Typical refresh rate for our screens is 60 frames per second. Okay, now we have these new iPads which have 120 frames per second, but for simplicity reason, let's think about 60. So if you want to move view from one point to another, so let's say from 0 to 10 over on the x-axis. So and we want to happen that this animation in 0.25 seconds, so quarter of a second. And as we have 60 frames per second refresh rate, so that means 15 locations together. So it moves like 15 locations. And if you take away start and end, like this counts in those 15 together as well. So we have 13 locations between to happen this animation. And we have other interpolation types, like ease in, ease out, and like linear default ones. So I think these built-in ones are quite sufficient for our needs. We can build our own, but then it can be quite tricky. But there are a couple of resources in the web. I'm not going to mention them here, so you can generate the code for you if you want to tweak really the animation. But here's a code example how we can set the timing function, this interpolation method. So with new Swift capabilities, we can use enum, so we don't need to stringly type it anymore as it was before. So we can use enum and specify if it's default, ease in, ease out, or whatever you need. So we just set the timing function property for the animation object. Next topic is animation types. So I would like to mention 3 of them. First one is basic animation, which is single keyframe animation. So we would say that's the most regular one we are using, we can use. Second is keyframe animations, so you can specify the keyframe values for each frame. But during this presentation, I'm not going to talk about it more because it's whole wider topic itself and deserves a separate talk. And the third one is grouped animations. We can group animations together. So let's say we want to animate view from one point to another, then we want to fade out, fade in. We can group these 3 animations together and work as a like combined one. And here is a little side note for all of us, that actually views in iOS are backed by layers. Again, I know what's happening with this Swift UI, so we need to maybe refresh after this WWDC, this presentation. So yeah, they are backed by layers. So if we need more lower level interface to visual content to our apps, or more flexibility with animations or performance, then we go one level deeper, the layer concept. Core animation is based on layers, and that means they are in 2D space. So there is no like 3D kind of space in there. But using core animation capabilities, we can achieve quite stunning 3D effects, like for instance, cover flow. So if we skew these album artwork, then we can see that it looks like 3D in 3D space. So later this concept was, it was presented in original iPhone, and later this concept was implemented in macOS in Finder as well. To understand more about views and layers, let's break it down and see how they differ. So views, on one side, they are more complex hierarchy, and we can use auto layout. Either we like auto layout or not, that's up to you to decide. But we can use it. They can receive user interactions, so like taps, pinches, gestures, and more, and clicks, and so forth. And often we need subclass many views, and there are high variety of views we can subclass and make our own views. And they are CPU powered, so they execute on the main thread. And layers, on the other hand, they are much faster, but they are more restricted, like not so many subclasses to use for us, but they are faster to draw, and there is no responder chain. And yeah, they execute faster because they are executed on another thread on the GPU. Let's talk a bit about CA shape layer. It's a specialized subclass of CA layer, the layer, that draws itself like the shapes on the screen, defining vectors. So if you want to draw this rectangle, then it consists of 4 vectors. And when we finish the drawing, then we say that it's finished, it's closed, and then we can set the fill color, for instance. And here is some code to show how we can draw a triangle on the screen. So first we need to create a Bezier path, and then here is the whole, like the drawing part, the actual meat of this, this example. So we move to the start point, and then we move to the next point, drawing 3 vectors, like we have drawn the triangle, and then we say that it's closed, the shape is closed. And then we assign to the shape layer, we create the shape layer, and we assign the path property, and we can set other properties like line width and so on. And then in the end, we add to the actual layer. Path animations are most powerful and complex aspects of CS shape layer. Using path animations, we can morph from one shape to another. So let's say here there's animation from triangle to rectangle. But keep in mind that both shapes, they need to have the same number of points they consist of. Like in this example, the animation looks quite ugly and not natural at all. And even if when we go to Apple documentation, they are warning us about that there are these online points and offline points. So these offline points are those points where algorithm is like, it doesn't know what to do because like what kind of animation the algorithm need to execute. So we can make this animation a bit better. These two shapes are consisted of the same amount of points. So these sides from the triangle move up, and it's much nicer animation, looks more natural. And here is a small code example how we can make animation. So before we need to see a basic animation object. And with new Swift capabilities, we can use key path. So we don't need to stringly type anymore. Using key path, we can specify what we want to animate. So here we want to animate the path property. Then we set the new value, what the animation what's the end value. So that's the new shape, the triangle shape. And then we can set other properties for our animation, like duration, the timing function, which I showed previously, the interpolation method, and other. And then in the end, we just add to the shape layer, and that's it. Then the animation starts to happen. But we can group multiple animations together. So let's say we want to animate from one triangle to rectangle and to another triangle. And how can we do that? We just create a basic animation, animation group object, and we need to use this property, which is animations property, which is an array which consists all of animations we want to animate. But keep in mind that if you don't want that these animations won't start everything together, then we need to set begin time for each of this animation in this array. And we can set these properties for animation group. We don't need to set this for each of this animation. So we can work as a combined animation. So in this part of my talk, I will focus on the background animation, what my designer wanted. So if you see here, these triangles are moving slowly, like making this lava lamp effect. And the idea came from lava lamp. So how it works that this liquid absorbs more heat, and it rises up, and it makes this nice and calming effect. So that was our goal, to create this animation. And this was my initial drawing board where I started, but my designer presented to do this animation. So together there are 30 triangles, and there are 24 different points connecting these triangles. Some points are out of the screen. And I was thinking a lot how to do this animation and how to make it. And I even visited Artsy Coco Labs in New York. And there, in the end, during this meetup, there are almost 20 different people just figuring out how we can do it. And when I left this event, Orta Terox and Ash Farrow, who are really great people in our community, told me that once you do it, please share with the community. So that's why I'm here. But yeah, so how did I do that? So let's go into deeper. So my idea was to use Archimedean Spiral to animate all these points. Archimedean Spiral is arithmetical spiral which moves away from fixed point with the and with fixed speed. So it creates these points on the way with constant velocity. And we can see Archimedean spiral also in nature and in architecture. And even Reichstag in Berlin, this main building, is the glass dome on the top of it is built using Archimedean spiral in mind. I won't go deep into math problems, but the one most important thing what I had to solve was a coordinate issue. That when you are using Archimedean spiral, all the coordinates are calculated in Cartesian coordinates. So that means from this fixed point, the distance, and then the angle. But in iOS, we are using polar coordinates, x and y axis from 0 point. And thankfully, math is quite easy. I just use trigonomical functions, and that's it. But to understand more how I can set all these animation points, of course, I went to Swift Playgrounds, so I think it's pretty awesome. We can just execute our ideas there and test out. And my idea was to create 500 different points for each of this point animation. And so I went to this Swift Playground to test all the math and everything. So you can see how these points are on the screen. But how it works all together like this animation. So firstly, I'm using core graphics to draw all these triangles on the screen. Why core graphics and why not images? Because for our clients, some of our clients, they need this background animation in their colors. So I actually need to draw them, not using images. And then all like these points are moving. Then I need to construct all the animations. So as you can see, these points are moving clockwise or counterclockwise in different radius. So they don't kind of animate in the same pace, and it's not same stuff for each point. So I need to construct all these animations together. So it's a background thread. So once I do everything there, then I send all this information away to core animation. And core animation is doing everything for me. So as it is GPU-powered execution on separate thread, so CPU is free for other purposes. So it's not slowing down our application. And I have open sourced this project in my GitHub profile. So you can, after this talk, you can go and check it out. Yeah, you can take pictures. So you can check it out how I actually did it. So if you have any recommendations or such, I'm happy to have those as well after this talk or as issues or whatever, or tweet me as well. To experiment with animations, it's quite tricky. And just go to the code and start typing and writing animations. It's quite tricky task. Like we don't know what to do there. But there are multiple apps we can use for our purposes. Like I personally like the most Kite Compositor. I think it's a really brilliant application. So I think it's like a sketch for core animation. So we can make animations in this app. We can actually even export Swift code as well. So we can import in our applications. But there are many other, like Flow, Haiku, and even Sketch with Anima plugin. But essentially, they work the same. But my preference is Kite Compositor. And there is really brilliant plugin by Sketch. I just discovered actually 2 weeks before this talk. It's called Spiral. So if you need spiral trigonomical stuff in your apps to draw, then you can use this plugin. It works really great. To wrap up everything, I have a couple of conclusions about core animation and animations itself. Sometimes animations can be too much. I have one example from my daily job. We spend enormous time to build one animation. We tweaked like milliseconds here and there and whatnot. Like animation was brilliant. It looks really great. But the thing was that it not even caused issues, like, but also people, like the visitors, didn't understand it. Like, it wasn't working. It caused so many issues. And 3 weeks ago, we removed this animation, and everything works. Like, everything is understandable. Even Facebook had this app, Paper. Maybe you remember that app a couple of years ago. It was so brilliant, like animations. You can swipe left and left, and it showed this news feed in so brilliant way. But even for me, it was like I couldn't use it. I didn't know how to use it. So sometimes you need to know when it's too much, because animations, it's cool tweak for your applications and systems or whatever, but you need to know when to stop. Core animation is really powerful and well documented by Apple, and it's quite old technology. So, and when I started to experiment with core animations and animations itself, I thought there should be like quite a lot of material out there. But when I went to Amazon and when I wrote core animation, there are just 2 or 3 books there, and they're in Objective-C. So I know maybe people are not talking about that, but it's really powerful framework, and we can make quite awesome stuff with it. And I want to say that hard things with animations is like it's quite hard to do. When you want something easy, then yeah, it's easy. But when you want something out of the bounds, like something extra, then it gets tricky. And like Little Prince said in the book, that nothing is perfect. So it takes quite many iterations to do, like to tweak all those animations. And that's fine as well. So thank you. I will be available for your questions after this talk or during these events. And yeah, thank you for coming and listening.
We have time. So we have time for several questions. Unfortunately, our mic doesn't seem to be working, so just raise your hand and shout on at the top of your lungs.
So I know you can't tell us what it just came out, but what's your initial thoughts on Swift UI and how that affects animations? I know Apple has some stuff built in, but does that excite you, or are you a little nervous that it could replace some stuff?
I think these animations in Swift UI are mostly like these UI view animations. So these kind of stock animations. But anyways, when we want something more like this background animation, what I showed, you cannot do this with Swift UI. So you need to go to core animation. And I just know from some various sources that Apple is using a lot of core animation inside for everything what they are building. So I think it's not going anywhere. But I would like to see maybe nicer wrapper for core animation, because it's more like C-type framework, which doesn't feel Swifty at all. So there are some nice additions like key path and these things, but I would like to see more. Yeah.
I wanted a talk about game animation with SyncKit, and the guy presented a way to create animations with SyncKit and get this animation and introduce into an app. What do you think about core animation and SyncKit animation?
Honestly, I don't have so much knowledge about SceneKit, but the thing is that you need to use assets there. So for my needs, I had to draw these shapes like with core graphics. So it had to be in different colors and such. So in SceneKit, you're using assets like images and whatnot. So that was I kind of considered that approach, but it wasn't for my needs. But I don't have more knowledge about game development, unfortunately.
How do you iterate when you're testing animations using core animation? Like, do you just like cycle them and like run them in the same to see how they play out? Like, is there a faster way?
first, what I do, I use this kite compositor. So I just, without the code, I just tweak like these properties. How do I want this animation, basically? Because in the code, it's not so easy to tweak, right? And the simulator was quite slow as well. But now today they told that simulator now runs on metal, so maybe it will be faster, right? So let's hope on that. But firstly, I try to tweak in these like apps, like for instance, Kite Compositor, and then I go to the code. But again, like my designer was sitting hours right next to my shoulder, and we were tweaking like this and that. So it takes quite many iterations to do it. Like there is no secret sauce.
Do you have places for inspiration for looking at animation?
Just actually see what Apple is doing as well. Like this really nice animation what they have in App Store. This apps today, right? When you click, it slides up. I think it's really nice animation. And actually, to replicate it, it's quite a lot of work. So yeah, just use applications and other like objects. Like for instance, this lava lamp effect. It's like this. Background animation is for waiting applications. So waiting is frustrating in general, right? So this lava lamp is more like calming. So need to somehow connect these physical objects to actual animation. So that's how I get sometimes inspiration. But that idea, lava lamp, wasn't mine. That was my designer's idea. Again, that's the thing. Like sometimes it's too much. Yeah. So yeah. So and also we need to think that there are so many folks who are using our applications and they don't see our animations. So they interact with voice, for instance. So we need to kind of so it shouldn't be that animation just happens for 10 seconds and then these people who don't see, for instance, or apps, they need to use this application. So need to think broader spectrum. So animations sometimes can be kind of hurt. So like I removed this animation and now it's like solved, but like I kind of turn back and undo that. But I mean, it's learning. Right, so that's all. Thank you. And I will be around here in AltConf, and yeah, catch me.